I guess being in a Java conference, this is probably a good show up for a session that doesn't have any code in it. So this is basically a talk about requirements. And especially requirements in service-oriented projects are hard to do. So what this talk is about is actually about a lot of the stuff that we've been doing over the years and looking at requirements in these kinds of projects and how we can deal with that. And we find a technique that we use in a lot of projects, actually. It's called smart use cases. And I'll show you a bit about how we use these smart use cases to actually steer our service-oriented projects. So there's a lot of examples from that as well, but there's no code in here. So first of all, let me introduce myself briefly. My name is Hoogendoorn, which is a rather difficult name in English. I work as a principal technology officer at Capgemini. That actually doesn't mean a thing. It means I'm involved in software development all of the time. That's what I do. I talk to clients, I work with clients, I do projects, I write code, I write books, I write articles, blog posts, whatever. And occasionally I speak at conferences around the world. This is my personal website. And the site here below, the smartusecase.com website, is actually the website where you will find a lot of stuff about these smart use cases and how we deal with them. Also how we estimate them, for instance, and how we build them, stuff like that. Here's my Twitter account. If you feel the need to Twitter about the session, please do. We love all the feedback about this too. So, okay, first of all, I'll skip this one. First of all, let me introduce you where I come from, because we're actually way out of another part of the world. So this little blue area here, it's called the Netherlands. This is actually the country that I live, and it's so small. If you drive 350 kilometers, you've been from the total north to the total below south. So that's it. So that's sort of like the same size if you go from here to the coast. So it's a small country, but we're a famous country. We're famous for our windmills, of course. People all know these things. They actually work. Well, not these days anymore. They're for show now, but for tourists. But it gives you a bit of an idea of what the country looks like, where I come from. And this is Amsterdam, of course, which you probably all have heard of. It's divided in districts, and the most famous one of all is named after a color, which I won't mention. And of course, this is one of our great painters. This is done by Vincent van Gogh. This is actually my favorite painting in the world. It's in Amsterdam in a museum. And if you go there once, you should definitely check it out. And tulips. Of course, everybody knows us for the tulip fields we have. And there's other plants where we're also famous for. So this is my backyard. No, it is. So I'm here to talk a bit about service orientation. So I'll start off a bit about why it's hard, why service-oriented architecture projects usually fail. And that's because they're so extremely hard. There's a lot of factors that deal with that. And I'll try to show you a technique that we use to describe the requirements in service-oriented projects that we use to define a good level of work in these projects. And I'll even show you a bit about how these teams work together. Some pictures of some of the teams that I've worked with over the past few years. So originally I did this talk at a conference in Brazil. And Brazil has an interesting capital. It's called Brasilia. And it's been built not over the last 1,000 years like the cities here and the cities in the Netherlands as well. It's been built in 1961. So they built the whole city in 1 year. And actually the original plan for the whole city, for the whole design of the city, is this 18-page document. And I was there, and I went into the museum, and I saw this. This is the original design. It only has 18 pages, and they built the whole city out of that. Wouldn't it be great if you could do projects just like that, have an 18-pager, and then build a huge project that lasted for years and years and years? Well, unfortunately, in most software development projects, that's not the case. So I'll start off with why service orientation is so hard. It is hard due to many factors. Usually, service-oriented projects are done by organizations that have a wide variety in systems that are in their systems landscape, which are really big and can be built in any language whatsoever. So there are systems in SAP, in PeopleSoft, in Java, in .NET, in VB, in Power Builder, in whatever you might have. So there's a lot of systems. I worked for a public transport company in the Netherlands, and one of the systems they had was actually an Excel spreadsheet that contained the whole price table for the whole of the Netherlands. And every time somebody has to calculate a price for a ticket, they went into the spreadsheet and took the price out and got it off. That's a really strange way of working, actually. But so in these projects, you will see that there's many different stakeholders because so many systems in an organization are used by so many different people in so many different departments that have to work together, and these systems have to work together. And when new requirements come up, new business processes that they want to implement or improve on, it's usually the case that there's a whole bunch of different departments in an organization, whether that's a bank or a logistics organization or a government agency. A lot of people want influence in your projects, and that makes them hard. And the second thing is that if you look at service orientation and maybe even cloud orientation, the fact is that systems in an organization are seldom just the systems in your organization. They usually interact with a lot of systems outside of your organization. And that makes it even harder because if you look at these systems, sometimes they're already in place, but they just don't offer the services that you need. Or sometimes they're not even in place and will not be in place before you have to finish your own project. So that makes it even harder. In the case of this public transport company, we have a new system in the Netherlands that you can scan your badge on a reader, and the readers are everywhere in the country, and this data has to be processed, and when you check out of the train again, you again put it through a reader, and then automatically a ticket price comes out, and it's all distracted from your account, etc., etc. So, but these readers that are all over the country, the software for that wasn't ready, but we had already had to build the software that processed the data. So that makes it hard in service-oriented projects. And again, usually due to the fact that these projects, or usually programs with a lot of projects in it, last very long, requirements change. Actually, requirements change in any project that you might have. And they will change on average between 20 and 25% in a project. Statistically proven, so it can be more or less. But anyway, requirements change, and especially if you're running a very complex project with a lot of enormous amount of requirements and a lot of technical requirements as well. If your requirements change, that makes it very, very hard. So, and then again, if you look at this, I haven't seen any technique yet that is able to describe all the requirements in all these different systems that you might have in your landscape, including the front end and the Java portals and the back end SAP systems and the middleware and the workflow engines and whatever you might have in this landscape. The thing is, if you start such a project, you need to make an estimate of the project. And because the requirements are so in a broad range, some are written in Word documents, some are not even written down, but just in the heads of people. Some are written by, or actually drawn by business analysts in all sorts of diagrams. So there's all sorts of variations, which makes estimation of this stuff really hard. And that's why planning these projects is even harder. It's very hard to design on a deadline for a project that you hardly haven't got a clue of how complex it will be. And then again, the next step will be, if you start building this stuff, it always becomes more complex than you think it will be. That's actually Hofstadter's law, which says things are always last longer, even if you take into account Hofstadter's law. So the same goes for these type of projects. So here's an example of a systems landscape that was in an organization that I was in. This is actually the systems landscape of the customer service departments of this particular company. It's a large company, it's based in the Netherlands, and each of these little rectangles is a system. And all of these systems act together. So each time they try to implement or improve on a new business process, for instance, they have subscriptions, so you want to upload your picture. Uploading a picture goes through at least 12 of these systems. And to them, that's a pain in the butt. To give you an example of the size of this landscape, this little pink rectangle here is called SAP CRM. I don't know if you've ever worked with this system, but it's huge. And it has, yeah, right. That's the same attitude I had. We once, for fun, just tried to count the number of tables in the database of SAP CRM in this implementation. So take a guess. It's a lot of tables. So what do you think is a lot? Take a guess. How many? 500? Do you think that's a lot? Well, it can be a lot. Well, it sure is a lot, but it's more. It's much, much more. So take another guess. Sorry? 100,000. You're laughing about it, aren't you? It's more. It's actually 142,000 tables in the database of this particular rectangle. So that gives you an idea. Not all these systems are that big, by the way, but this is actually the biggest one. This is even bigger. So all these systems work together. So this is a pretty complex field to work in. So what if we have to deal with, in our projects, implementing new business processes throughout this landscape? That's very hard. And it gets even harder because we worked in releases. There were 4 releases a year, so we have 3 months to build the new software. But since the landscape was so complex, it took them 7 weeks after we built some software to be able to test it out through the whole landscape. So if you have 13 weeks, there's not much time left. So each time the landscape gets more complex, the time you have to build the software gets smaller and smaller. Until at one point in time, you probably don't have any time to build new software at all. And that's the challenge they are actually facing. So, give you another example. This is actually coming from a web shop that we built for a particular client in the Netherlands and Belgium. And it's a web shop that actually sells software out to universities, schools, elementary schools, and all kinds of schools in the Netherlands and Belgium. And this particular picture, which is a sort of like strange UML diagram containing actors and components and whatever you might have, this picture alone is the login procedure for this system. So there's actually an Active Directory on the right side of it. So there's so many different ways of getting into the system. You can imagine the size of these systems if you take into account the whole system. So that's why they are difficult. So what do you do? Well, so why do you do them at all, by the way? So first of all, as I said, organizations will have less and less time to develop new software, to implement new features, to meet the requirements that the business actually have. Because the business in companies, they will think of new products and new things to do. Well, even before we turn our heads, they've thought of new things. There's new products coming out, and you need to be able to support that. And once your landscape gets more complex, it becomes much, much harder to be able to do that. Maintenance is, it's dreadful. They have departments full in this company who only maintain one particular system. And they want to get rid of that. So that's what they are doing. What they actually are doing is saying, you know what, we're going to try and get rid of some of these systems in the landscape to make it more maintainable. So to be able to do that, what they needed to do is put in place a service-oriented architecture that has a service bus in the middle, has a number of front-end systems using the services that come out of the landscape, and a lot of the other systems only provide services. So if a particular system, like this one, which I can't read anymore, provides, let's say, 6 different services to this service bus, it becomes much easier to cross it out. Because if you can find another system that can deliver the same services, and they're actually trying to migrate them all to the SAP systems, then you will be able to get this system out, making your landscape smaller and easier to maintain. So that was their basic target in doing these projects. So they had a whole series of projects lined out, and they're still working on it. They have been working on it for about 3 years now. But this is just an example of how complex this stuff is. So, and this is basically what we tried actually to do to help them out and to find out the requirements for these different systems and the services they deliver. This thing is called a smart use case diagram. And this is basically what I will try to talk about in the rest of the talk. Every oval in this picture is a use case. Traditional use cases, as you might know them, usually if there are any diagrams, because usually they're a large bunch of text, if there are any diagrams, they probably consist of about 2 to 3 different ovals. And we have multiple ovals, so to speak. As you can see, it's also a working document. People write on it and they spill coffee over it. Not on purpose, but they do. It's because it's on the table and people will sit around it and talk about it. So this is the stuff we are doing. So I'll show you a bit about, I'll leave this over. I'll show you a bit about why we use this technique and how we use it and what it helped us to be able to work in this landscape. And as we speak now, they have built up a repository of hundreds of these smart use cases, these very small use cases. And right now what they're doing is, if a new business process comes along, they'll just pull together the use cases from the model, pick up the new model, see what's new, see what's already there, and build the process, build the only steps that they still need. So they're gaining in speed in that. So let me show you the approach for doing this. Basically, this picture shows well, let's say the first half of the approach. Next to that comes, development, testing, stuff like that. Also should be in the process, but this picture basically shows the approach of getting to these smart use cases. And I will elaborate on that. Usually, if I do a 2-day training course on this stuff, I can talk about this picture for at least an hour, but I only have got about 2 minutes to do that. So I'll do the brief summary of that. I'll just switch off my screen. Oh, I didn't even know I could do that. That's cool. So usually, you start off in a project looking at the scope of your project. In large organizations which have these particular complex landscapes, usually you are looking at implementing a bunch of business processes. So that's the first step to do. If you look at the scope, find out what the business processes are that they actually need. So you talk to the business, you talk to the business analyst, and usually it's the business analysts that come up with lots of diagrams. The funny thing about business analysts is that they're not standardized. So depending on who you're talking to, they might have a diagram A or diagram B. They invent their own diagrams using Visio or using PowerPoint for that matter. And you have to find out what's in there. And I have a picture of some of these pictures in here too. So you find out what the business processes are that you need to improve or need to implement new. And the next step is, you can actually do this one step further. Actually, this model with the cloud level, kite level, sea level, and fish level comes out of a book by a guy called Alistair Cockburn. It's a book called Writing Effective Use Cases, which is a very good book about writing use cases, but not about modeling use cases. So basically, the next level would be, if you would take each of these business processes, or clusters of business processes, you can delve down one level deeper. So we actually identified that there's 2 different categories. First of all, there's a category that is still a cluster of processes, like you would have authorization. These individual rectangles could be something like log in, log out, change password, do authorization, whatever you might have. And the other side of that is that there's also like chronological processes. So for instance, if I'm going to India, we have to book a trip, we have to book 4 plane tickets, we have to book a taxi, hotel, stuff like that. And there's a lot of steps involved in that. Usually business processes, the important business processes, are like this. And this is why we start modeling them out at one level deeper. So there's an interesting thing about business processes. Is that if you look at business analysts, what they do, if they start modeling, they will model out the business processes independent of the technique they're using up to the same level. And this level is usually referred to as elementary business processes. And they're quite easy to recognize because there's a guideline to it. And the guideline, it actually says AutoPOP. It's an acronym, of course. It says one time, one place, one person. So if a process is executed by one person at one location, at one point in time, it's usually an elementary business process. Things like apply for subscription. If you want to read a magazine and you want to have a subscription to a magazine, or book a ticket, or make a reservation for a theater, whatever. Those kinds of processes are elementary business processes. And that is where use cases come in. Use cases traditionally live at this level, at the C level. So what we found out a couple of years ago, actually about 10 years ago, is that if you look at the elementary business processes in any of these business analyst pictures, it's usually the case that every of these elementary business processes can also be a use case. So they're sort of like similar. They live at the same level of granularity. So you could easily have a use case that says, apply for a subscription. And you can delve into that. Well, the problem with that is that in traditional use cases, you reach the user goal. You try to establish a goal for a particular group of users, like apply for subscription. And the thing is, these things can be rather complex still, because the level of abstraction is still not detailed enough. So for one example, we were doing a project at a bank, and they were writing their own use cases. And they had use cases at this level. Now, use cases are usually written down in, you have actors and you have goals. I'll explain that a bit later on. And there's a basic flow, and there's alternative flows to the basic flow, and alternative flows to the alternative flows, etc., etc. So what happened at this particular bank is that they had a use case, or they had a lot of use cases. One of the use cases, which is a very good, wrong example actually, it consisted of 65 pages of text, which for a developer is quite long. Developers don't read text. We look at pictures and think, okay, we can build this stuff. Cool. Let's go out there and do this. So it had 65 pages of text. The basic flow for this use case was 12 pages long. So there's 12 pages of steps that you needed to implement to be able to do this business process. And there were over 100 alternative flows, which means that there's exceptions. You can go either way with each of these alternative flows. So having 100 alternative flows means that there's 100 square scenarios at least for going through this use case. So if you're a developer, that's impossible to build. Actually, they failed at it, by the way. The project failed miserably, and they restarted it, as you should do as software development projects. But if you're a tester, it gets even worse. Because what testers do is they actually try to identify all of these scenarios and write test cases for all of them. And that's a hell of a job if you have 100 square scenarios. It's impossible. So at some point in time, we figured out that in the model of Alistair Coburn, there was another level left, which is called fish level, and it's also called sub-function level. So what we did is we actually tried modeling out the use cases, and actually we coincidentally started with this, I think it was about 12 years ago, when I misread a book on use cases. That happens. So we started modeling out a level deeper, and it actually worked out quite well. And until people started telling me that that's the wrong way of doing use cases, but still they haven't convinced me, and it works really well. So we create a whole bunch of additional use cases to this single usable level use case. And the whole thing together is what we call the smart use cases. So I'll give you some examples. So this comes from a project where this is actually the whole project. It doesn't really matter which technique you use for this upper scope thing. You had a question?
The smart use cases are more detailed than the fish level, than the sea level?
They're smaller. They're a lot smaller. But if you look at the way that you describe them, but we'll come to that later, it's still the same way of describing them, only they're a lot smaller.
I mean that are they more granular than sea level?
Sorry, come again?
Are they more granular than sea level?
Yes. Yes. That's exactly the point. That's a very good remark. So I'll show you diagrams in a minute. So this is actually the top level diagram that you would see in the approach on the left side. It doesn't really matter which diagram technique you use. You can do it in PowerPoint using an organizational chart, for instance. That works really well. By the way, if you start doing this stuff on a whiteboard, make sure it's really white whiteboard, because you will have a lot of these things, and you will identify the first level of processes. If I look at my current project, which is a 2-year running agile project, we had the scope of the project, and underneath were the clusters like contacts, membership, offices, reporting, authorization, stuff like that. So that's the high-level groups of processes that you can identify in these pictures. And it's actually pretty easy of drawing up these high-level pictures. Most business analysts already have these pictures in place. They know what's in here. So they know what's in the landscape too. So the next step is, if you would look at this particular one, which is in Dutch it's called beheer debiteuren, but that doesn't have any meaning in English. So it's more like manage your customers, something like that. So if you look at this process, we actually took it to the next level, the kite level. So out comes another diagram. In this particular case, it's an activity diagram. It could have been a BPMN diagram or a BPL diagram or a flow chart or whatever you might use for this. It doesn't actually really matter, as long as you can identify that it's a chronological process, it has its decision moments in it, and it has steps. Well, each of these particular steps in this process is actually at the Autopop level. So these are handled at one location, at one point in time, only not by one person, because these are steps that are handled by a system. By the way, it's an SAP system in this particular diagram. So since they're at Autopop, we can switch to use cases now. So we're drilling down into the use cases. So where's the use case diagram? Here it is. So this is the same thing as the spotted out rectangle on the previous slide. And these are the additional use cases that we added to it. So now there's 6 of these use cases implementing this particular process step. And the funny thing is, usually you're used to use cases that interact with your user interface and interact with your users. This diagram doesn't. This is actually a diagram that sits in an SAP system. These are all services implemented in SAP. So the interesting question would be how to come from this big use case and extract all the smaller use cases from it. So over the years, we've gathered a number of guidelines to do that. And this is the list. Actually, it's also on the website, www.smartusecase.com. And the funny thing is, it's a wiki, so you can extend the list if you would like to. So don't hesitate to do that. So for instance, if we see reuse in an element in a larger use case, we usually extract it. For instance, if I would have a use case that says, register call in a call center application, one of the first steps would be to find out who the customer is who's calling. The customer is calling, hey, my washing machine broke down, can you help me out? And then you first need to identify him. So that will be a sub-function level use case called search customer. And why do I pull it out? Well, for two reasons, to be quite exact. Is first of all, probably if you build a call center application, a use case called search customer can be used in a number of different processes. So you identify reuse early on. And the next is that we usually say, well, don't use more than one form in a use case. So a use case is like a controller, and it handles a form, and it communicates with the form, and it works as the controller for this particular form. So that's another reason of doing that. And if you build portals, we usually say also that if there's web parts in the portal, they usually have separate functionality. So each of these web parts can usually be modeled out as a sub-function level use case too. And we do that too with reports and services. And the interesting part is that over the years we figured out that you could also do this for the services in your backend systems. And also for the process orchestration that you would have in the middle in your service bus. And that's what we figured out during these projects. So basically, if you look at these diagrams, the smart use case become our unit of work in these projects. And usually I work in agile projects, even SOA projects can be agile, by the way. And it's all work in progress. It's not a static diagram. It grows, and people pull things out of it and put other stuff back. And so this is a particular interesting one. We usually hang them on the wall in projects, and people write on it, and it's a nice thing to look at. And the funny thing is, it's a very good means of communication between all the different roles in your project, because stakeholders will be able to read this. Business analysts can read this. They even can draw it. Information analysts, developers, testers, even application management people can actually read and interpret these diagrams because they're so easy to draw. So this particular one, for instance, is one that's coming out of an SOA system. There's a bunch of use cases in this one that are actually in the Java portal for this particular system, or actually in this particular landscape. And the colored ones are actually all orchestration that sits in the middleware of this landscape. And the ones on the right, you cannot see that here, but they all have different colors in the color diagrams, are all services that come out of different systems. So this is actually putting together the whole business process in perspective. So the next step, of course, would be, if you've identified all these use cases in your landscape, is you should probably write them. You know, in an agile project, as I'm always in, and have been for the last 15 years, we usually draw the models, the use case diagrams, early on in the project. So that will be, the funny thing is, like an approach like Scrum does not really have an approach to dealing with requirements. They say, well, you should have used user stories, put them in your backlog, but how you come to these user stories, nobody will tell you. So you have to find out yourself, which is good because it adds a lot of flexibility, but it's also not a good thing because in these complex projects, it's very hard to get these requirements across. And writing a bunch of user stories doesn't work. So you do the models early on in the project, and when you start building them individually in your iterations, that's the point in time where you will write them down. And usually there's a fixed template for doing that. And the template usually, because there's a lot of different templates. If you look at use case templates at Google, there's so many different alternatives to do that, but basically they'll come down to this. There's actors. Actors are actually the roles of people, or they can be other systems as well, that execute the use case and benefit from executing it. So use cases always have a goal. So you write down the goal as well. And they have pre and post conditions. So the preconditions of a use case is actually the stuff that you need to do before you can actually run the use case. It's the stuff that needs to be valid before it can execute its steps. And once it executed its steps, the use case, it will meet its post conditions. So this is the stuff the use case can do for you. So for instance, if I have to look up a customer in an SAP system, I could define a use case that is called find customer, which some sort of ID comes in, and out comes whatever the SAP system spits out as the customer. Hopefully it's something like a JSON object or, I don't know, some piece of XML or whatever you might have. So it can be all kinds of different stuff. But that's the post condition for the use case. So here's the customer you were looking for. Or it could be that you've given it a wrong ID. So there's no customer with this ID. So it needs to be able to have another post condition, a failing post condition, for if you put in the wrong ID, or if you put in null or whatever you might do. So there's the post conditions. And the next step is, I'll show it in a picture, by the way, that's much easier. The next step is that use cases have a basic flow. The basic flow is a series of steps that you can take, and they're either taken by any of the actors or by the system that is underhand, that you need to take to reach to the positive post condition. So there's no if and else in these basic flows. The ifs and elses that you might have, they actually appear in the alternative flows. So for instance, in step 3 or whatever, the system sets the status of the driver to the default status active. This is actually a pretty simple use case. So something might go wrong here. If it does, you will add an alternative flow, which is another piece of text, another series of steps that start off here and could end the use case, maybe in the negative post condition, but could also come back to another step here in the use case. And that's where it goes off, because in traditional use cases where they're only at usable level, and then you start writing stuff, there can be so many alternative flows, as I mentioned in the example earlier on. So that's why we took it one level deeper to the smart use cases. So, and the next step would be, and that's actually also in the approach, but it wasn't in the picture, is that you're also able to test this stuff. Testing use cases should be rather easy, because there's preconditions that you need to meet, and if the preconditions are met, it's a black box. And what comes out of the use case is actually, it makes sure that the post conditions are met. So you can actually check for the post conditions. So outside of use case, calling the use case would actually be pretty simple. You can actually test that. You can test that automatically, by the way. I did another talk earlier on at the conference. I did it twice. How to implement this stuff. So how to build web applications out of smart use cases. And it's probably a videotape, so you can look it back if you want to. There's also stuff in there for how to unit test this stuff. So basically, if you test the use case functional, that means you have to look at the different scenarios. Testers do that. If you have real testers in your project, so not programmers who write unit tests, but testers, so that's a different breed of people, by the way. They think differently. They see things we as developers don't see. We always look at the positive side of things. They always look at the negative side of things. So we say, okay, we've done this, it works, and then the tester comes in and he says, so what if I press this button without filling in that field? So what happens then? And we ask I didn't think of that. We'll write something for it, and then he comes in and says, yeah, but what if this happens? So that's the role testers have in projects. If you're in a traditional waterfall project, that's bad, because you're usually in a waterfall style project, you don't start testing until you've finished coding. So if you've been coding for half a year, and the tester comes along, and on the first day he says, sorry, there's a bug in there. Well, the first thing that comes to mind is kill him. So in an agile project, it's differently, because these guys work together at the same point in time on the same use case. So they together set up the design. I'll show you some pictures of how the teams work together on this. So basically what they do is they do another diagram, and actually there's modeling tools that actually can generate these diagrams from the basic steps and the alternative flows in your use case description. And this is basically what they test. They find all the scenarios in there, and they test these scenarios. They write test cases to it. So the next thing that we actually found out is that over the years, we've seen that modeling a lot of these systems, there's a lot of standard types of these smart use cases that we find out. For instance, a very simple one would be a search use case, as we call it. That would be like, I have a web form, I need to search for a customer, I can type in some criteria, I press submit, out comes a list of customers, I click one, and that's it. I've reached my post condition. So that's a very simple, straightforward thing. We call that a search. And we've identified over the years that there's a whole bunch of these standard types of use cases that you can use in your modeling to more and more standardize this stuff. So there's a whole list of this stuff out on the smartuseCase.com website. There's about 30 of these standard types. And we use them a lot because what we also do is use them to generate code from the use cases, either in Java or in .NET or whatever you might do, or in JavaScript as you want to do that. Oh, I guess someone's calling me. What? No, not anymore. So if you look at service orientation, there's a few things you can do with these smart use cases to extend even further. First of all, usually, this is just an example architecture, of course. Usually there's an enterprise service bus in the middle, which handles the services and which you can call the services in. There are systems delivering services, and there are systems that need the other services. So that's basically a very basic service-oriented architecture. All these pop-ups. So there's systems that consume services, and there's systems that provide services. And we found out that we can actually model that in these smart use case diagrams as well. So we actually came up with that there's two types of these smart use case diagram in these kinds of landscapes. And the first type would be from the user interface, from the actual user, the end users of the system. So this is all user interface stuff. So this can be, I don't know what, a Java portal, an ASP.NET web application, or a SharePoint application. Well, perhaps. And these diagrams run over to the middleware. So the red ovals here, the red use cases, as each oval is a use case, are actually use cases that are in the middleware in your ESB. So they do the workflow, they do the process. So this is the first type of use case diagram that we use in these systems, or in these projects. And I should get rid of all these text boxes that I add on. It's just, shouldn't do that, by the way. So, and then there's the other half. It's once you get to the middleware, going to the back-end systems. This is a very simple example of that. This is actually business services requiring a whole lot of other services. They get aggregated, and they give back a bunch of data, probably in XML format. So this is the other half. So this is from the middleware onto the back-end systems. And that gives a very good modeling, very straightforward and easy modeling technique for identifying all your services. The good thing is, if you do this in a good modeling tool, and there's lots of good modeling tools out there, then what you could do is build up a repository of use cases. So the landscape I've shown earlier, it had about 40 systems. And what these companies are currently doing, or they have been doing that for a couple of years, is organizing all the services they have in the different systems, in different folders in the modeling tool, with all the smart use cases in it. And it also makes it easy for them to be able to see, okay, this system still has only 4 services left. Isn't it time we get rid of this thing? So what other systems can take over these services? So it gives you a very, well, simple technique of dealing with the services in your landscape. So then you have these diagrams. This is a real-life example. The other one was too, but I recolored it. So this is a business services, and this is actually BPM stuff that takes place, in this case, in SAP PI, I think. So this is process stuff that actually processes this request, and it goes into the back-end systems, and it does a lot of stuff, gets data from the back-end systems. In this example, for instance, this particular small use case, it's actually, the last time we looked, in 15 different processes. But it's only built once, and it's been tested once, and it has run ever since. So that's a good thing. So these things are all in different systems. So this is in SAP, this is in PeopleSoft, there should be some Java projects in there too. And this is actually going to an outside system. So there's actors, because this is an actor, also on the right side of these diagrams. That is where we cross the boundary of our own organization. So we go into another organization and ask them for some data probably, or in this case, send some data to it. So this is a system that is outside of the organization. So it's also an easy way to identify where we go outside of the organization. So once again, all these text boxes, I'm just going to clear it. So you can put them together. So this is a combination of 2 diagrams, actually. It's a combination of a front-end system, which is actually an ASP.NET-based call center application. And this is a bunch of SAP stuff, again. Well, there's lots of SAP out in the world, and we have to deal with that. There's no way around it. So this is SAP ISU, which delivers one service. This is SAP CRM, delivering another couple services. And this is the middleware stuff. So this is where it's brought together all of the use cases from the front end all the way into the back end systems. So another example is this one. This is the one I've shown before. So the orange ones are the Java portal for this particular customer client. These are customer-facing. So there's about, I don't know, they have about 50 million customers in the Netherlands because everybody uses this website. I can't tell you what it is, but it's, well, let's say it's frequently used. And these use cases that have the web pages with them, they actually trigger into the middleware and delve off the BPM services. And they go out, and there's some orchestration here and some aggregation of stuff. And this is, again, SAP systems, PeopleSoft systems. This is actually a backend .NET system. I'd never seen that before, but it was a system entirely built in .NET that just delivers services. Well, you could do that just as easily, of course. And this is the whole thing brought together. So that's an interesting technique, we think, in doing projects. And since they're all standardized, it's also very easy to estimate them, because the level of granularity of these smart use cases is more or less the same. So there's a very easy estimation skill. So it allows you to, even with only having the model, without having all the text within the use cases, you're still able to make a fairly good estimate. And we actually do this in project. And they estimate, since they're an agile project, so they know what, after having done 6 of these projects, they know what their productivity is. They actually do 35 smart use case points per iteration. And that gives the project teams enormous power, because the last time I was in the organization, they were starting a new project. And the business owner, the product owner, or the business analyst, they had identified 620 smart use case points together in new stuff that they wanted to implement. And actually, they had 10 iterations to do that. So the team said, we're unable to do this because in 10 iterations, we'll be able to deliver around 350 smart use case points. So deal with it, customer. Instead of saying, okay, we're going to do this and we're going to do overwork and whatever we do and get additional developers on board and additional testers and whatever you might have. So they just said, no, we cannot do that. So skip half of the scope. And they did. And then the project ran on time. So it's a good technique for doing that too. So some of the last slides is how these teams work together. Usually if we do these agile SOA project teams, there's teams that, this is actually a quote from, I think it was the CEO of, I don't know, what, Amazon or whatever. They call that 2 pizza teams. It's actually, teams have the size that you can feed with 2 American-sized pizzas. So they're usually pretty big. And so this is a team of about 12 people, and that's a good team to start. And as you can see, so I've put up the people in this team. This is a really strange team. Usually in an agile project, you will have a developer or a couple of developers. You might even have a tester. There's an agile coach or a scrum master or a Pokemon trainer or whatever you might have. And there's the customer. In this particular team, we had 2 business analysts who drew up a lot of these pictures, 2 information analysts who are responsible for the smart use cases. We had an SAP CRM consultant who was actually the most expensive guy in the project, 2 middleware developers. We had an ABAP developer, which is the programming language you use in SAP, which is a horrible programming language, by the way. It's even worse than VB. It's just plain ugly. There was a .NET developer that, by the way, was also a Java developer, 2 testers, and a Scrum Master, and an Agile coach, which was me. So this is actually a really strange setting of a team, and we got them to work together on these smart use cases. So we started off modeling the business processes at a very high level. So this is actually where it happens. All of these guys are standing, and one girl, are standing around a whiteboard, drawing up all these high-level business processes. And later on, we put them in a tool. So it's even with the business. So this guy is actually the product owner for this project. He is from the business. He is collaborating here with the information analyst, the CRM consultant, the enterprise architect, the developers, and the testers even. So they're all together in this. And that makes it really, really valuable. And then we start modeling use cases, of course. So this is just an example from another project, by the way. And then we start estimating them. And this is actually a fun picture because this is a colleague of mine. It's probably taken here in Bangalore. And we estimate usually these smart use cases with the whole team. So there's a scale to it. In agile projects, there's a technique called estimation poker. And we use that a lot for these kinds of estimations. And we can also do it, you can also do it quickly, just going through the diagrams with the whole team and adding a number to it, because the scale is pretty simple. It's 1, 2, 3, 4, 5, 8, and 10. That's it. So you can easily assign these numbers to these use cases, and you will have an estimate for your project. And then we start designing them. And this is an interesting picture because in the design, you would expect there to be designers or information analysts. In this particular picture, which didn't contain the whole team, by the way, this is the tester in the project. Why is he in the design session? Well, because he has to look at the different scenarios in the project, and in this particular use case, I mean, and he can actually look at the exceptions. And if you look at the exceptions before you start building this stuff, it will save you a whole lot of time. And your quality will improve very fast. And this guy is actually the middleware developer. A very good developer, by the way. You probably never heard of him, but he's a good developer. So the next step will be looking at the design and trying to implement it. And again, it's different roles put together. Actually, here's the developer. This is the ABAP developer who knows all this strange code. And here's the tester and the analyst, and here's me acting as a coder in this project because there was also a big .NET part in it. And we're looking at this stuff and implementing it right away. And after that, right away after that, you start testing it. So the developer goes off and builds it. The tester goes off and writes the test cases and the test scenarios, and you can test the stuff. Again, with the developer and the tester together. So it's not people in different worlds working together on an occasional basis. They work together on a daily basis, implementing all these services that are in the system, use case by use case. And then in the end, you try to accept this stuff. So you might ask, why is the tester accepting the use cases? Well, a lot of these use cases that we had in the project were services. And they spit out XML. So there's no way that end users of this system can accept these use cases, because no end users wants to look at a piece of XML that contains a whole lot of data. So here, the tester is responsible for accepting the use cases. So that's the way we worked at, and then you acceptance test, of course. That's the way you can use these smart use cases in, let's say, agile service-oriented architecture projects. And it works really, really well, I can tell you. So since I'm running out of time, I'll leave away the takeaways. This is the website on smart use cases, which is called smartusecase.com. Actually, you have to put in the www before that, of course. It's also known with a very long name because this is the name of our agile delivery platform. Here's my email address, my Twitter account, if you have any questions. I'll be here for another half hour because I have a conference call. Thank you for being here, and I hope you have a great last session, I think. There's only one after this one. And then we're done for the day. Okay, thank you for being here, and have a good day and a good travel home.